Okay, so our last topic for this first unit is to talk about percents. To understand percents, we actually have to break down the word percent. The word percent is actually made up of two words. Per, if you think of like miles per gallon or dollars per hour, it's for each or out of. And then cent. If you think of cents in a dollar or years in a century, it is 100. So percent literally means out of 100. So like 34% means 34 out of 100. It's a ratio or a fraction. If we're going to convert percents, in fact, it's just that simple to convert a percent into a fraction. 34% is 34 out of 100, or 34 over 100. Now, from what we've seen with fractions, we're not going to leave it as 34 over 100 because we can reduce it. We can simplify it. Both 34 and 100 can be divided by 2, which will give me 17/50ths. So let's try a few. Let's take 68%, which is going to become 68 over 100, and then reduced by, we can try 2. We see both of them are even. That would be 34 over 50. Are we done? No, we can also still divide by 2. So 17/25. Or we might have 40%, which is going to become 40 over 100, and reduced by 10. We could have reduced by 4 as well, yes. So dividing by 10 gives us 4 over 10. We can still divide by 2. Give us 2/5. How do we deal with something like 12.5%? Well, it's still 12.5 over 100. Only we don't like having decimals within our fractions. So to get rid of that decimal, the typical way of doing it is just to move the decimal point over. What we're really doing is multiplying by 10 or 100 or 1,000, depending on how many places you need to move it. Here we need to move the decimal point how many places? 1, so we're just going to multiply by 10. If we needed to move it 2 spots, we would have multiplied by 100 and so on. Now in a fraction, if you multiply the top, you have to multiply the bottom by the same thing. So 12.5 times 10 is 125. 100 times 10 is 1,000. And now we can reduce this by dividing both of those numbers by 25 will be a start. That'll give us 5 over 40, and they can still be divided by 5. Give us 1/8. We might have 765%, which will become 765 over 100. Now the first thing we see here, well, there's a couple things we'll see. We see that it can be reduced. Both of them can be divided by at least a 5. But also it's an improper fraction. Now when it's at a 100, it's probably the easiest time to take out the whole number portion. How many whole pieces or how many hundreds can come out of 765? 7 of them. That'd be 700, so it'd leave us with just the 65 over 100. Now the 65 over 100 can be reduced by 5. 65 divided by 5 is 13. 100 divided by 5 is 20. All done? 13/20ths? I've got to remember the 7. It's 7 and 13/20ths. Anytime we have a percent that's bigger than 100, 100% means 100 out of 100, or 1. So anything that's bigger than 100, we better have something that's bigger than 1. How about this one? 18 1/3%. How do we write that if it's a fraction? Well, still 18 1/3 out of 100. But we don't like having fractions within our fractions any more than we like having decimals within our fractions. So how are we going to get rid of that fraction? Well, you could try that. The only problem is 1/3 is going to be 0.333333333. So there's no way to move the decimal point far enough to get rid of it. You could do that. 18 times 3 plus 1 is 55 over 3. When you have a fraction, to get rid of the fraction, you would multiply by a common denominator. Well, in this case, the only denominator is a 3, so 3 would be the least common denominator. If I multiply the top and bottom of this fraction by 3, this becomes 3 over 1, so the 3's cross-cancel. That's 55 over 1, or just 55. On bottom, it's 100 times 3, or 300. And now that can still be reduced. Both of those can be divided by 5. Give me 11 over 60. What do you think? Well, we can also convert our percents into decimals. We started out with 34%, and we said that became 34 out of 100. To turn a fraction into a decimal, we simply divide. 34 divided by 100. Well, if we divide by 100, it just moves the decimal point over 2 spots. So 34 divided by 100, 1, 2, it becomes 0.34. So when we're changing a percent into a decimal, all we're doing is dividing by 100, or moving that decimal point over 2 spots. So we might have 59%, which will become 0.59. 40% will become 0.4. So you could say 0.40 if you wanted to, but you don't have to. 8%, 0.08. 3.2%. 0.032. Yeah, you got to remember you still got to go 2 spots, so it's 0.032. Yes. No, if it's just 0.032, that's okay by me, but I will tell you this, when you get into the dosage calculation tests, they're very picky about that. Because like 0.8, that decimal point, if it's not written dark enough, is really easy to miss. So you might interpret that as an 8 if you're reading quickly. But if there's a 0 in front of it, that tells you there's got to be something going on there. So it draws your attention to the decimal point. That's something they just changed in the last 1.5 years. On the dosage calculation test, you must have a 0 in front of your decimal point. I don't care so much for this class, but it's something to get used to. How about 520%? .2 or 5.20, yes. And then 1/4%. This is always a tough one. A lot of people want to say 0.25. 0.25, though, would be 25%. Number 1% is 0.01. 1/4 has to be smaller than 1. 0.0025%. Or 0.0025. Because this is 0.25%, then you still got to move the decimal point 2 spots. This whole idea here, when I threw out the 1%, that idea of benchmarks is huge in math, and in percents especially. Since I know that 1% is 0.01, I know that any fraction of a percent that's smaller than 1 has to be smaller than 0.01. So it keeps me from making that mistake of just throwing out that 0.25. Because that is very common. Let's go the other direction. If we have a decimal, let's make it into a percent. Well, 0.38 is a decimal. That's 0.38 out of 1. A percent, of course, has to be out of 100. Now, one way we can do that is just multiply by 100 on top and bottom. 0.38 times 100 is just going to be 38. And that's probably the simplest and most typical way of converting from a decimal to a percent. Now, we know that if we're going from a decimal to percent and we're multiplying by 100, all that's going to happen to our number is we're going to move the decimal point 2 spots back the other way. So 0.38 becomes 38%. 0.71 becomes 71%. 0.4 becomes 40%. Yep. 2.9 becomes 290%. And 0.053, 5.3%. Good. Next, we need to be able to go from a fraction back into a percent. Let's start with an easy one that most of us know. 3/4, of course, is what percent? 75%. Now, if we didn't know that off the top of our head, there's a few different ways we could actually go about solving that. We could do 3 divided by 4 and get a decimal of 0.75 and then just move the decimal point. Or we could read that as 3/4 is 3 out of 4. A percent is out of 100, so we need to know how many out of 100 that is. And we could treat it like fractions and say, okay, we got to multiply by 25 to get 100, multiply by 25 to get 75. So it's 75 out of 100. Or the most common way of dealing with it is a process called cross multiply and divide. You can cross multiply 3 times 100 is 300. And then technically what you would be doing is multiplying the other way as well. 4 times whatever this is, 4 times x would be 4x. And those two numbers have to be equal to each other. 4x equals 300. But the shortcut is just cross multiply. 3 times 100 is 300. Then you divide by the number that's on the other diagonal. Divide by 4 gives us 75. So if I have 3/8 and I want to convert it into a percent, I'm going to say how much out of 100 is that? Well, 3 times 100 is 300. Divided by 8 is going to be 37.5. So 37.5 out of 100 is 37.5%. Or we might have 5/7 as a percent. So again, how much out of 100? Cross multiply. 5 times 100 is 500. Divide by 7 is going to give us 71.428571 approximately. So that's about, what's that? Yeah, it'd tell you whether to round it to 1/10 or 100th of a percent. Let's say it's telling you to round to 100th of a percent, so that'd be 71.43% is what you'd end up being. But yeah, somewhere in the instructions of the problem, it'll say to the nearest 10th of a percent or nearest 100th of a percent. So we can convert percents into fractions and decimals and then back again. Let's look at what we do with these now. Now I mentioned that word benchmark. And benchmarks are actually just huge in percents. They're very powerful, although a lot of people they do them mentally a little bit, but they don't really acknowledge what they're doing. Benchmarks are easy percents to calculate. For example, let's say I have the number 2400. That is the full amount, or 100%. 10% is pretty easy to calculate. 10% is 1/10 of 100. Well, for 1/10 is moving the decimal point over. So 10% would be how much? 240. Good. How about 1%? 24. Perfect. We can get the 10% and the 1% just by moving a decimal point. 10% is one decimal place over. let's say we have like 5,730. 10% is just going to be moving the decimal point over one spot. It's 573. 1% would be moving the decimal point over another spot. 2 spots total, or just one more spot past the 10%, would be 57.3. Like that. Any questions? Now there's beyond those, of course, we would have like a 50% or a 5%. 50% is just half. In this case, we can pretty easily calculate half of 2,400 is 1,200. 5% is half of 10%. Half of the 240 is 120. Or 5% can be thought of as 1/10 of the 50, so you just move the decimal point over one spot. But anyway, once you have those benchmarks, you can start calculating percents. If I want to know 26% of 2,400, I can do 10% plus another 10% plus 5% plus 1%. 10% would be 240, another 10% would be 240, 5% would be 120, and 1% would be 24. You can add those all up. You do 624. 26% of 2,400 is 624. Or let's say you wanted to find 49% of 820. Or sorry, 8,200. That is 50% minus 1%. Well, 50% is half. That would be 4,100. 1% would be 2 decimal places over. That's 82. So 4,100 minus 82 is 4,018. It's 49%. So you can see we can get some percents really quickly using those benchmarks if it's relatively simple numbers. Or at the very least, we can use it to get an estimate of our percent so that once we do the calculation, we know whether we did it right or not. Let's say I am asked to do you know, 58% of 2,615. Well, I'm just going to do, as an approximation, 60% of 2,600. I'll use that 60% is 50 plus 10. 50% is 1,300. 10% is 260. I'm expecting an answer somewhere close to 1,560 out of this. So now when I start punching numbers in my calculator and I do my calculation, if I come up with something way off from that 1,560, I'm going to be suspicious. I'm going to double check it. Well, with that said, let's look at how do we do the calculations then with the percents rather than just taking the benchmarks and adding them up or subtracting. Let's say I am told that blank is 60% of 90. When we're dealing with a percent problem, I always start with a percent, whether it's a simple percent problem like this or whether it's a word problem. So here we have 60%, that is 60 over 100. And now to finish off our proportion, we simply have to decide what matches up. There's 2 other numbers in this problem. One of them matches up with the 60. One of them matches up with the 100. Remember, 100% is the full amount, or all of it, or the starting point, or however you want to think of it. 100% means one, or the whole thing. Then the 60% is just the piece of it, the portion of it we're looking at. Well, in this problem, it's pretty obvious. Blank is 60%. So that missing number, or the blank, matches up with the 60. Of 90, well, you could reword that a little bit if you wanted to and say out of 90, which kind of cements that 90 goes on the bottom. And now to find the missing number, it's just cross multiply and divide. 60 times 90 is 5,400 divided by 100 is 54. They might be written out a little differently, different order like this. 30% of 20 is blank. Well, I start out with the percent again. It's 30% is 30 out of 100. And now I got to figure out what matches up with the 30 and what matches up with the 100. Well, 30% of 20, if you think of that as out of 20, would seem to indicate that 20 goes on bottom. Or 30% is blank, seems to indicate that blank matches up with the 30 again. And then we can cross multiply and divide. 30 times 20 is 600. Divided by 100 is 6. Let's say 45 is blank percent of 150. Now I said just a couple examples ago that I always start out with the percent. But in this case, the percent is missing. But I'm still going to start out with the percent. That missing percent is blank out of 100. And now 45 is blank percent. So 45 matches up with the blank out of 150. So 150 goes on bottom. Cross multiply and divide. 100 times 45 is 4,500. Divided by 150 is 30. So that is 30%. 45 is 30% of 150. This one's similar. 48 is blank percent of 40. So that's blank over 100. Now in this one, the 48 matches up with the blank again. It goes on top, so it's out of 40 on bottom. We notice that this top number is larger than this bottom number. What's that going to tell us about the percent? A percent is going to be bigger than 100. 100 times 48 is 4,800. Divided by 40 is 120. So 48 is 120% of 40. Here we have 36 is 90% of blank. We have our percent back, so we're going to 90% is 90 over 100. 36 go on top or bottom? On top. 36 is 90%. So we will cross multiply and divide. 100 times 36 is 3,600. Divided by 90 is 40. So 36 is 90% of 40. So this one, the order is a little different, but actually the same type of problem. 80% of blank is 48. Well, 80% is just going to be 80 over 100. 48 go on top or bottom? Top. 80% is 48. So we'll cross multiply and divide. 100 times 48 is 4,800. Divided by 80 is 60. 80% of 60 is 48. So you can see these proportions. All you have to do is you set up the percent as a percent over 100, and you match up the other two numbers. And it's always cross multiply and divide. Now, some of you may have been taught something called the rate method of percents, which is what I was taught when I was young. I like the proportion method a lot better because to me it's a lot easier, a lot less to remember. What the rate method of percents was, a rate is just the decimal form of a percent. So what they did with that was they had to convert the percent into a decimal or a rate. So 60% here would be 0.6. And then you use that in the calculation. So for here it would be 90 times 0.6, which would give you 54. So 54 is 60% of 90. Actually works pretty slick, and it's really quick. Same down here, 30% is 0.3, so 20 times 0.3 gives us 6. So on problems like that, it's really quick and simple and easy. Problem is, not all the problems are like that. We could come down to this one here, 90% is 0.9, but it's not going to be 36 times 90%. Here you have to remember it's going to be 36 divided by the 0.9 to get 40. So once you've changed it to a decimal, you would have to remember, do I multiply or do I divide? And even you have problems like this where this would have been 48 over 40. We don't have a percent, so you divide. 48 divided by 40 is 1.2. Then you move the decimal to make it a percent, 120%. So you can see if you use that rate method, there's 3 different procedures you got to remember, and you have to figure out which one to use. If you use the proportion method, it's just percent over 100, and you match up the other 2 numbers, the calculation will always be cross multiply and divide. That's why I like the proportion method. As long as you can get the numbers in there in the right place, the calculation is always the same. You don't have to decide, do I multiply or do I divide or do I move the decimal? It's all right there for you. And the other thing I like about the proportion is when we get into word problems, everything really kind of falls into place. For example, let's say that a certain dosage is 2% of body weight. If a patient receives 0.8 kilograms of medication, how much do they weigh? So here we have 2%. That's 2 over 100. So I always start out with the percent, even on the word problems. And then I try to define what do those pieces mean. What does the 2 stand for? And what is 100? Now remember, 100 is always either the whole amount or a beginning value. The top number is the specific piece that we're looking at. Now 2%, the 2 is standing for the medication, because the medication is a portion of their body weight. The 100 then is standing for their body weight. So now, over here, we know the 0.8 kilograms. Does that stand for their body weight or the amount of medication? Medication. So setting it up in a proportion like this for a word problem, it's actually easier to do this than it is the generic problems, because each of those numbers has meaning. We need to make sure that we put the numbers that have the same meaning together. And now we cross multiply. 100 times 0.8 is 80, divided by 2 is 40. So that patient would weigh 40 kilograms. Any questions? Okay, well, I think I've talked for enough. Really, to get good at the percent problems, there are going to be some word problems in the book. Make sure you pay special attention to those. The only way to get good at them is just to do them and get used to them. But there is page 23 out of the book from last week that we didn't get to last week. That's 1 through 21, the odds. And then there is page 36 through 37, which is the percents. 1 through 51, the odds. And then page 39, 1 through 12 there that you can look at doing the Roman numerals. Now again, I'm not going to collect your homework and grade it, so you don't have to do every one of them if the first few are easy. In fact, I usually recommend that you skip ahead to the more difficult ones and make sure you got those down. Next week will be our test. We're going to try to finish the test in the first hour so that we at least have 45 minutes to an hour to lecture on new material after the test. If any of you want to come in early, I will be here probably by 8 at the latest, usually 7:30.